I am really wondering who actually wrote these notes, did this summarization. Was it a human power or was it a software? I have the pleasure now to welcome Mark Cieliebak, a top expert exactly in this field. Mark is Professor for Natural Language Processing at Zurich University of Applied Science, and he's CEO of Spinning Bytes, a startup that specializes in innovative solutions for text analytics and speech processing. So curious to know who actually wrote these summarization notes. Pay attention to especially people at home. I would like to have a question at the end from the platform audience. Thank you. Mark, floor is yours.
Thank you, Philip, for the introduction. So I'm very pleased to be here. I actually do not know who wrote these notes, but at the end of the talk, you might know whether they could have been generated automatically or not. So I would like to start with something which is kind of a little bit embarrassing for me, but I'm optimistic that you will understand why in a second. So a couple of years ago, 5 or 6 years ago, I gave a presentation on machine learning and how it works and this breakthrough of deep learning. And I was asked to also make a prediction what will happen in the next years. And this is what I predicted. No, this is not what I predicted. This is what I predicted. So in 5 years, that was 2015, we will have a player in ping pong which plays with a human on a reasonable level. So this was done, I think, a year later. It was already published and produced a ping pong machine. So it didn't work. It was too early. Then I said 10 years later, we might have a machine translation system that works on par with a human translation. Now, you probably all know DeepL, which came out 2016, 1 or 2 years later, and it's really good quality. Then I said 10 years later, we might have self-driving cars, and this bus runs in Sion in Switzerland, self-driving since 2016. So it was much faster than I expected. So the only thing that I promised was summarization will take 25 years at least to be at a reasonable level. And today I would like to talk about whether this is true or not, whether it's still an open problem or not. So text summarization comes in 2 flavors. The first one is extractive summarization. So you have a text, and basically you select single sentences and say, now, these are the most 5 important sentences, and this is a summary. This gives you a decent idea what is the text about, but it's not really a summary, and it's very hard to really understand what the text is about. More interesting is abstractive summarization, where you take a text, try to digest the content, and then generate a new, much shorter text, maybe 5 to 10% of the original text, which gives you the main ideas of the text. And this is what I'm going to talk about, abstractive summarization, which is one of the challenges. So what can you summarize? You can either talk about single documents, short documents like news text or a short essay, or longer documents like a scientific paper or maybe even a book. You can summarize meetings, and you can summarize how-to videos. There's research basically on every of these domains going on, and people try to work on this and try to focus on one of these document types. And on the other hand, you can talk about multiple document summarization. So you have a huge document collection like tweets from 2020 or a news stream or thousands of scientific papers, and you want to know what are these documents about. And you want to have a short, digested text which gives you a good idea of the content. Now, how does it work? I would say this is kind of the standard model for abstractive summarization nowadays. This is an encoder-decoder model. I will not go into the technical details, but just give you an idea. So this model basically takes the original text, which is something like England emerged victorious in, and then it goes on how England wins something, maybe in a soccer game or something like that. And this text is completely digested and modeled in an abstract representation in the computer, word by word, basically. And this model is, say, a very long vector of numbers, which represents kind of the content of the document. And then in a second phase, we have a decoder, which generates a new summary, and it does it word by word again. So it generates at first the word England, and then it takes the output, England, and its complex representation of the content of the document and what it has already produced, and produces the next word, wins, and then the next word, and so on. So we have two phases, the encoder, which understands the document, and then we have the generation phase, which generates word by word how the document is summarized. Now for this, what you need is this phase here, the embeddings phase, where you take the text document and try to represent each word as a numerical vector, because the computer can only read numbers, so you need to represent the text as numbers. And this embedding phase, this had made tremendous progress in the last years. So originally, this only said something like, oh, there is a word and it's England, but I don't know anything about it. I don't know it's a sequence of characters. And over time, the models have increasingly understood, in quotation marks, what the meaning of these words is. And how does it work? So these embeddings are trained on huge numbers of documents, so millions of documents, and we give them to the computer to read the text and try to guess what are words in the text and how to represent them. So how does it work? We give them a text like the cat sat on the map, but we leave one of these words out. And the model has to learn what might be a proper word, which is here in the gap between the four words. And if it has learned this from reading large numbers of texts, then it can represent the word set with a corresponding vector. So giving it all Wikipedia and all internet documents, it learns how words and which context they are used. And then you can see that it understands, for example, what are similar concepts, like what are countries, what are cities, and stuff like that. What are verbs? You can read it. And this has been done in 2013, and at that time it was really breakthrough to have these representations. So you get a vector out of that, which is here the vector of set. Now, since then, it has improved dramatically. 2018, a new model came out, BERT, and this had a more complex task for the computer to solve. So it took not only 4 words, but a complete sentence, and it masked, so it hid several words, like this one, which is Harry, off, and written, and K. Oh, that's the name of it, yeah. And then the computer had to predict not only one word, but it had to learn to predict many, many words. And this was trained with a much larger model on much more data and got a much better feeling of what the text is about. And now in 2020, a new model came out, which even took it one step further in the direction of summarization. So this is especially done for summarization. Forget about all the technical details here at the top. Here at the bottom is the word. Pegasus is mythical. It's a pure white. It names the model. And here, it was 2 steps. One was, again, to mask several words, like mythical and names, but they also masked complete sentences. So from the information Pegasus is, and then it, the model had to learn how to predict the sentence in between. And this was done for important sentences which were found with extractive summarization. So it learned to generate the important sentences from the context. Okay. Now I skipped some slides, so I go back. This was then fit into a much more complex model, and this is then the basis for the summarization model, which means we take these representations of words, and this helps us to understand the context of the content of the document, and then generate word by word output. Now, there has been a lot of different technologies on top of that to build these models, but in principle, it was all about the word embeddings. Now, summarization has one problem, and the problem is that we don't have sufficient data to train it on. Now, getting a good summary for a text, writing it, is a lot of effort, so you cannot pay people to generate millions of summaries or by hand. So we take usually some kind of summaries like news text and the headline, and we assume that the headline is the summary of the news text, which can be true or not. So many of these data sets are pretty small. There are now some large automatically generated data sets, but it's still a reasonable short list if you compare it to other, text classification data sets, which are much larger. There is much more abundance of data sets around. Second problem is that you have to judge what is a good summary. And here, well, it's not really clear. I mean, you write a summary, I write a summary, and it's very different, and we don't know which one is better. Now, the computer generates one, and the way to compare it is we just count the overlap of words, basically, with some human-written summary. So we don't know exactly if it is a good or bad summary. We just know what is the overlap of words. OK. Now, we did that in 2018 using this pointer network, and it generated summaries, so headlines for English text, which works decently well. So this is text about soccer, and it's, here on the left-hand side is the generated summary. Joachim Löw signs his contract by another 2 years until 2018. Great summary, it's correct. This is a reference which was human-generated. And we said, oh, that's cool, it works. We worked together with some media and said, now we can generate headlines. So they gave us German documents, German news articles. And sorry, it didn't work always. So this is a counterexample of bad summaries. So it was something like in English, 50% were good, 50% were bad. But then we turned to the German articles, and it turned out that it didn't work at all. We couldn't generate German headlines, and the reason was not German, but the type of headlines. So in English, in the CNN dataset which we used, the headlines are kind of summaries of the content. Gaddafi calls for UN to investigate NATO attack in Surman. Pretty nice summary of what it's about. Now, jetzt wankt das Butterkartell is probably not a decent summary of what is written in the text. Or something like, okay, so we had a lot of examples. So the German headlines were much shorter and didn't really summarize the content. It was more like a teaser to make people read the article. So this kind of failed at that time, but not due to the technology, but more due to the type of summaries that should be generated, or type of headlines. Now in 2020, we again applied the state-of-the-art system, MAS at that time, to generate summaries of news articles, and here's one example which was generated. It's a longer summary, really a summary text. So it says, Jerusalem syndrome is characterized by 7 stages, including anxiety, agitation, and nervousness. Sufferers are consumed by a need to be clean, and so on. So it reads really like perfect text, and for news text, it really works decently well. So you can summarize news text. You can also summarize something like scientific articles, which are well structured. You can summarize Wikipedia pages at these days. So as I said, we have made some progress in the last years. This is the so-called Rouge score. This is a leaderboard, a public leaderboard of the best systems that exist in the world. And this basically counts, this Rouge score, the overlap between human summaries and machine-generated summaries. So the better, the more likely the system is to generate decent summaries. And I would say now this BART system is quite good, so you can throw in some reasonable fluent text and you get a summary out of that. Now what we want to do as a next step in our university is take it to the next level and apply it to meetings and interviews, which is totally different, because you have spontaneous speech, you have automatic transcripts, which are anonymous, and then you have something like a dialogue structure, and you have to summarize what people said in response to other people. So there's a lot of challenges going on there, and since 1 year, this has been a very active research field, and people try to understand how to do that properly. Because if we apply these standard methods to dialogues, it doesn't really give any reasonable result. You can imagine if there is a discussion, do you want to buy this product? Oh, I don't know, but it's the best product. Oh, then I buy it. And you want to summarize it in a standard way, then you lose this notion of the dialogue, basically. Okay, so going back, my predictions, I would say I would try to correct this 25 years. I'm pretty sure that we have already summaries for fluent text, or consecutive text, which works very well. For other domains, like dialogues, we are still far away, so it's work in progress. Thank you very much.
Thank you very much for this really exciting talk and the Butterkartell. It's a good one.
Yeah. I didn't know how to translate it.
It seems you're quite strong in predictions, actually. So who will win the European Championship in soccer? You said England?
I didn't say it.
No, but it was in the presentation?
It was past tense, didn't you see? So I wouldn't predict it. I mean, I failed in 3 predictions out of 4. So, yeah.
So any question from the audience? From the people in front of the screen? You should use maybe these human-crafted summarizations as an input data set. You said the missing data is an issue.
Yeah.
So here we have some good writers. You can use this in your data set by them. Can you link these technologies to the machine industry like predictive maintenance? Is it completely different if I have now sensors? A machine has a different cycle, probably behaving a little bit different in the morning and in the afternoon.
Okay.
Could you use similar techniques to make a summarization of my machine performance for the day?
Wow, that's a tricky question. I would have known it beforehand. I wouldn't know how to do that because the machine data is basically numerical data already. And I mean, there is predictive modeling and stuff like that. So if you want to predict how it might continue, if you want to summarize it, I wouldn't apply summarization. I would apply text generation. So this exists. So summarization is kind of really focused on summarizing text, but there is methods for generating text on numerical data. So you have a lot of examples on describing your data, and then you have a new data set, like what your machine did over the day, and then you can generate a text which puts into the slots the corresponding data. So we did this, for example, for product reviews. Mm-hmm. So if you have a restaurant review and you know how the restaurant, which numerical data it has, then you can generate a sentence which describes the restaurant, if this is what you were asking for.
Yeah, it's just exploring.
Yeah, so this exists. There is some research field on this, and that works if you have sufficient amount of training data. So if you have already a lot of data where you described your numerical values, then you can do this, yes.
We have a question from the audience. You just please stand up. The microphone is highly sensitive. You can rest there. Just ask. Speak a little bit loud.
So I have a question concerning differences of summaries. Let's say I want the summaries of the 5 recent articles published in a specific field. Mm-hmm. And now I want to know, let's say, everything about whatever, automatic driving or whatever. And then I want to know what's the difference between the different papers of different articles. So the difference of summaries.
Okay.
Can you do this already?
I am not aware of what has been done in that area. So the question is, I don't know if I have to repeat it for the audience? Or
no.
That works. Okay.
Yeah.
Okay, so I would say it's very hard at the moment. I mean, we still try to solve this problem of summarizing the papers, even for many papers, and giving a decent summary. So this is one step further. I would say it's not yet possible, but I'm not sure. I don't know the research there. Yeah.
Something to work on.
Yeah.
We have one question from the audience at home. So what about the impact of text that is not well formatted? OCR, I guess, about pictures, this kind of
like
things.
I said, in dialogues, you have the recording of the dialogue, and then you have an automatic machine transcription system which generates the text, but it's not perfect, so there is always errors in there. And this kind of hinders a good summary, because you have errors in that, and these errors are really wrong stuff. Now, if you have just written text, which is only not well formatted because it's social media text, user-generated or something like that, that shouldn't be a large problem. So that should work.
Combine it with lip reading, image processing.
Yeah, right.
So we have time for one last question from the audience. What will be the next step in using automatic text summarization for business use cases in different sectors? So we had newspapers, you elaborated already in summarization of meetings.
Yeah.
Do you think about other areas as well in the business?
Yeah, I think one business area will be to tackle all the documents that you have on your hard drives. I mean, you have thousands, millions of documents stored about all the projects that you did. They are with text, and then you don't have any overview what it is. So getting an overview, what is here, what is there, will be very, very helpful for many companies, I think.
Smart search engine for the own.
Right. Well, not on a search engine, because search engine, you always know what you are looking for, but reverting it and saying, now, these documents are about these topics, and then you get an overview.
Looking forward to that one. Thank you very much, Mark.
Thank you.
Welcome here.
Oh, thank you very much.
The conference is only possible due to your contributions. So, Mark, thank you very much.
Thank you very much
for being here.